Good evening, everyone. My name is Mansi Ahirrao, enrollment number ADT23 SOCB 0589, roll number 17. Today we will examine the architecture that enables Netflix to deliver seamless streaming services to millions of users worldwide. Netflix employs a microservice architecture. What is microservice architecture? It's a design approach in which an application is composed of multiple small independent services. Here, in microservice architecture, each service is responsible for a specific function, such as user authentication. It can also be like content discovery, video streaming. So, these services communicate with each other through well defined APIs. So, what must be the advantage of this architecture? The advantages of this architecture include scalability, ease of maintenance, and the ability to update or deploy services independently without impacting the entire system. So, in the step 1, we have client request. So, on the left side of the diagram, we have the client devices such as smartphones, televisions, gaming consoles, or web browsers. When a user initiates an action, such as logging in or selecting a title to watch, the request is first directed to the AWS Elastic Load Balancer. This component distributes incoming network traffic evenly across multiple servers to ensure availability and optimal performance. um, AWS Elastic Load Balancer also helps in some ways. Like example, a new episode of an incoming TV show has been released. So when the episode gets released, multiple users will stream the Netflix, like click on the episode at the same time. To avoid buffer, the elastic load balancer expands. So our cloud also has characteristics like expanding and shrink when the user grows. Now, next is the API gateway. From the load balancer request process to the API gateway. The API gateway acts as a single entry point for all client requests. It is responsible for routing each request to the appropriate backend service and enforcing security policies, managing traffic, and handling authentication and authorization. So, our next step is application APIs. So once routed, requests are processed by specific application APIs. Example includes Sign Up API. Sign Up API handles new user registration. Discovery API manages browsing, search, and recommendation functionalities. Play API initiates and manages content streaming. So here, each API operates as an independent microservice, enabling Netflix to develop, deploy, and scale them separately. Our step 4 is additional backend services. This application APIs often communicate with additional backend services to retrieve or process information. For example, the Play API may query services that provides video file location, subtitle options, or digital rights management data. Our step 5 is cache layer. To improve response time and reduce load on the database, Netflix utilizes a cache layer. Frequently accessed data, such as trending titles or previously retrieved metadata, is stored in this cache so that it can be delivered to users rapidly without repeatedly querying the database. Our sixth step is the database layer. If the required information is not found in the cache, the system queries the database layer. Netflix uses different types of databases to store various kinds of data, such as user profile, watch history, and content metadata. This specialization helps maintain efficiency and scalability. The step 7 is data communication between services. So, all the services and databases exchange data continuously. For instance, when a user watches a title, this event is recorded and shared with other users responsible for updating recommendations, tracking user engagement, and optimizing streaming performance. So, our step 8, stream processing pipeline. Netflix processes vast amount of real-time data through its stream processing pipelines. The key component includes Kafka. Kafka captures streaming events such as plays, pauses, and searches. Apache Spark streaming cluster. It processes these events in real time. Elasticsearch cluster enables rapid content searches. AWS S3 provides reliable data storage, and Hadoop supports large-scale batch data processing. This pipeline ensures that user activity is analyzed almost instantly, enabling accurate and up-to-date recommendations. So, for the conclusion, in summary, Netflix microservice architecture routes each user's request through a sequence of components: the load balancer, API gateway, application APIs, cache, or database, and in parallel, the real time data processing pipeline. This architecture allows Netflix to deliver personalized, high quality streaming experience to millions of users simultaneously while maintaining speed, reliability, and scalability. Thank you so much. Thank you. Have a nice day.